well, what is science? What are we talking about when we talk about science? And this is a question that's going to come up over and over again for these first couple of weeks, right? Because we're going to see a bunch of people saying, I think I've got a proper account of science, and then we're going to see it fail miserably. And we're going to see somebody else try to give a different theory of science. And that's just going to go on over and over again. This is, as philosophical as a question as you can get. I suspect there's very few scientists that would remotely find this an interesting project, right? But anyways, what is science? One of the things you might want to do if you're asking that question is you might want to try to distinguish science from the things that it's not, right? So you might ask the demarcation problem, the demarcation question. What makes science different from other ways of approaching the world? Does science have a distinctive method? We often think there is, right? We call it the scientific method, and in fact we teach that in school. And as you go on, as we get into this course later, right, we'll see that the textbook model that many of you are going to be teachers, right, that you teach in schools that I was taught in, grade school, does claim, look, there is this method. There's a methodology to the sciences. We're going to see a lot of people say that's almost certainly wrong, and that's not the way to understand what's going on in the sciences. But I mean, that's a way a lot of people think about science. There's a distinctive method, the scientific method, and that's what sort of demarcates science from the other things that you might study in the world. Okay, so let's suppose science has a method. Well, what kind of things are science? What are we trying to describe, right? So often when you're doing philosophy, right, and you're trying to give a theory of something, a really important question to ask right at the start is, well, what is the stuff? What is the phenomena that I'm trying to give an account of in the world? So, I mean, if I'm going to ask, well, what is science? I have to know, well, what are the sort of the paradigm things that my theory has to account for, right? Because if my theory can't account for these things, well, then my theory of science is wrong, right? So, bare minimum, right? Classic physics, that it's often taken as the paradigm example of, science, right? And so we start looking at that, and you go, well, right away there's a problem saying, well, science is, physics is science, right? Because theoretical physics, when you start thinking about how theoretical physics works and the types of things that theoretical physics is focused on, theoretical physics often departs quite dramatically from the types of things most people think of as real science, right? Because often people think science is something like, we come up with a theory and we test that theory by observing facts or data in the world. And so science is giving us that, right? It's giving us the official truth about the facts as we observe them in the world. So let's just say that's our first brush at an account of science. Well, right away, you throw in theoretical physics, you got a problem, right? Because theoretical physics has very little interest in an observable world. Theoretical physics is increasingly focused on the types of things you might think of as philosophy. Is focused on things like abstract mathematical and theoretical models that have little to nothing to do with the actual world understood as this kind of place out there that we can go observe, right? The focus is much more on things like possible worlds, ways of sort of building a model that is internally coherent and consistent. And very often theoretical physics is focused on the possible and possible worlds rather than actual worlds. But yeah, physics, right? That's something we should get into an account of science. If you haven't accounted for physics, there's something wrong with your theory of what science is. Now our text says, look, math shouldn't be treated as a science, right? Often people think about math and they go, well, math's so authoritative and so black and white, which isn't really how math works. But say the math must be the kind of thing we're going to call science. Our text says we shouldn't treat math as a science. We're going to treat physics as a science, but not math. And the reasons they reject math, they say, well, look, math doesn't rely on experimentation and observation at all. Mathematics has a methodology that's fundamentally different from the sciences. The maths are in the business of deductive reasoning, not inductive reasoning, not abduction. Again, I've got a video that's going to go into deduction and induction. So if what I just said there doesn't make any sense, that's the video you should watch. But mathematics uses a very specific kind of reasoning and it's very specific kind of goals that tend to depart from what we think of as science. Mathematical abstractions don't have to have anything to do with the actual world, right? The focus in mathematics, again, is on possible worlds and on what's entailed by certain assumptions, right? So when you're doing math, right, what you're often doing is you're saying, look, given these assumptions, this is what's logically entailed, right? This is what comes out of my assumptions. But that doesn't necessarily have to line up with the world at all, at least whatever we're going to call the actual world. It could just have to do with possible ways the world might be. So mathematics is not really a science. It's its own separate kind of way of thinking about reality. So we got physics in there. Probably the other two things we should have in a model of in an account of what science is, right? We should have chemistry and biology, right? Those seem to be the three core sciences, right? Physics, bio, and chem. So if I'm giving you a theory of science, that's what I should be talking about. Physics, biology, chemistry. Now you might want to include some other stuff, right? You might want to talk about earth science, atmospheric science, oceanography, perhaps portions of computer science. Neuroscience seems like a candidate. And then some of the other brain sciences, right? These are the kinds of things, if you're giving a model of science, that our text thinks these are what you should be giving an account of. What makes all these things the same and what makes them distinct from other ways of studying the world? That's the question we're asking, right? Because that'll give us a philosophical account of what science is. Is it their method? Can't be their topic, right? They're all talking about radically different things. Maybe it's something else. Sometimes people want to include applied sciences as sciences. Again, our text is going to say these things aren't science. So what are applied sciences? This is stuff like applied computer science, engineering, technology, medicine, the trades, right? Our text says, look, these are all valuable, they're all interesting, but they're not the type of thing that we're interested in when we're talking about what science is. Why? Well, because applied sciences apply existing models and theories to solve current problems, right? So you're not doing fundamental research in an applied science. You're not generating a new theory of reality. What you're doing is you're taking a theory, right? Whether it's, the theory of evolution, and you're applying it to disease in medicine, and then you get something like the germ theory of disease, right? That's not anything new. That's just, hey, look, this is what we believe the biological world's like, and so we're going to apply it in a medical setting, right? And so you're just working out the implications of a already pre-existing theory. Why? Because you want to solve a problem, right? You want to do something real, and you want to do something useful in the world. You want to make people new products for people to use, or you want to improve public health or something like that. The natural sciences, unlike applied science, are engaged in fundamental research. They create new knowledge as opposed to applying existing theories. So our model of what science is, it shouldn't focus on these things, right? Although this is generally where the public sort of interacts with the sciences, right? We talk about STEM research, right? Again, most of you are going to be teachers, and there's this sort of push to have better STEM education. But often what we mean, right, or often what the money is tied to when somebody says we want STEM research is not science research. It's not even math, right? It's not science education and math education. It's tech education and engineering education, right? We want people to have these practical, real world, job ready skills, right? Well, maybe that's a valuable thing. I'm not saying it's not. I'm just saying that that's not really science education. That's TE education. And often the way the public interacts with science is not with science itself. It's with this stuff, the applied sciences, which again, very valuable. Really horrible sitcom, The Big Bang Theory, right? But there's a running gag in there. You've got this theoretical physicist who's autistic, right? Sheldon. And then he had a friend, Wolowitz, who was an engineer, right? And it's a constant joke, and Wolowitz goes to he works for NASA at one time, and he goes out into space. He does all these amazing things, but he's always getting made fun of by Sheldon and even by his friends because he's just an engineer, right? And there's kind of that attitude here. It's not that it's dismissive, right? And that's not what I want to claim. These things are no less valuable. It's just they're distinct from what we're talking about when we talk about science. Because what we're talking about when we talk about science, at least for a philosophy of science course, is not the application of theories. It's the theories themselves, right? What makes a scientific theory distinct from, say, a theological theory or a philosophical theory, if anything? right? I've got STEAM down there, right? STEAM is art added to the STEM. So, right. So if you had a STEAM education instead of a STEM education, you'd study things like history and philosophy and psychology and the social sciences and fine arts, right? But STEM is, very explicitly let's downplay the arts education. That's not really the important thing. Let's focus on tech, engineering, math, and science. But anyway, the social sciences and the humanities, we should say something about them as well. These are typically, although historically this is not true at all, but today, typically, the social sciences and the humanities are generally not considered science, right? Humanities, for sure, right? We're like the bottom of the barrel when it comes to, areas that have prestige and, with the general public, right? History, English, philosophy, religious studies, cultural studies. These are not science, right? And the methodology of the humanities seems quite different from, I think, a public understanding of the sciences, right? The humanities seem to work by logical inference, by introspection, by interpretation, right? You look at an English professor, you look at what they're doing. They're reading a text, they're applying a theory about how to read text, and then they're interpreting the text in light of that. Or maybe they're introspecting, how does the text make them feel? What's the reader response to the text or something like that? What are philosophers doing? Philosophers are building models, and they're worried about logical inferences and logical coherence and consistency and, argumentation, right? Very different than whatever scientists are up to. So, so humanities are not typically thought of as sciences, but that said, the lines between all these things are very weak, right? And they're fluid. Many of the humanities have adopted the methodologies of the natural sciences, of hypothesis formation, observation, model building, experimentation, falsification. There's a whole branch of philosophy called experimental philosophy that really just takes upon the methodology of the statistical sciences and uses statistical inferences and empirical observation and experimental design to try to address and add to philosophical discussions. That doesn't look like traditional humanities at all. That looks more like science than anything at all. The social sciences have always been highly contested. Is sociology a science? Is economics a science? Is psychology? Are they more like the humanities? Well, they spend a lot of time focusing on qualitative research. Or are they more like the proper sciences? Where do we put them, right? Depending on what kind of model you give, you're going to have different answers to these questions. Perhaps given the prestige the field has in a society, maybe that's what's going to do it. Like you look at the brain sciences, they've been very successful over the past century. You look at the early 20th century, psychology was a part of philosophy, right? If you were a psychologist, like people like Carl Jung and Sigmund Freud, they would have, and William James, they would have been in philosophy departments. It's really mid 20th century that you get psychology as a separate discipline, and you start putting people into psychology departments. So psychology would have been very firmly in the humanities. It would have been a sub branch of philosophy, right? And then what's happened? Well, I mean, there's been theoretical changes and paradigm shifts and all that kind of stuff in psychology. But what's really happened over the past century to psychology is just the prestige of the field has changed, right? Psychology became much more respected as an academic discipline. And I guess philosophy and the other humanities became much diminished in regards to their respect. So you might think, well, it's not that they have really different methodologies. It's just we have more respect for them as fields, and so we treat them now as a science, and that's really what's sort of generating the social science distinction. If we think about the field as sort of deserving a certain kind of social cachet, we call it a science. If we don't think about it that way, then it's we'll call it a social science or maybe even a humanities. Same thing with computer science, right? Again, early computer science, not really considered science. Computer science very much today, as much of a science as you can think of as anything. Look at the difference between anthropology and archaeology, right? And anthropology, particularly cultural anthropology, right? That's sort of the branch of anthro that gets picked on the most, right? It's the least sciencey of the anthropologies, right? Whereas something like physical anthropology or primatology, or maybe archaeology proper, right? Those are getting closer to being real sciences. So maybe this has a lot to do with social cachet and power, or maybe it does have something to do with method. Just this distinction being as partially social, right? You think about philosophy. Even today, if you go down to the US, right, in California, philosophy is considered a social science. It's not considered a humanities at all. Whereas throughout much of the rest of the Western world, philosophy is sort of a paradigm example of a humanities, right? So these distinctions are in a lot of ways arbitrary. But you might want to go, well, what is this kind of, what is the core thing that makes science science and makes these other things not science if they're not science? And one of the reasons, as I've been discussing, is that a lot of this has to do with social status. Many people view the phrase science as a mark of a certain kind of prestige and authority, right? When we call something a humanities, that doesn't mean, like, look at Jill Biden, right? Dr. Biden. She's got a PhD in education, right? And, the writer for the New York Times, right? Was it the New York Times or was it the Wall Street Journal? It doesn't matter. A newspaper reporter, had the, felt like they could just write an article where they not only called her kiddo, right, but they said, "Who do you think you are to call yourself a doctor?" Right? You with your PhD in education. You're not a real doctor. A real doctor is somebody that's delivered a baby. And then you think, well, does that mean that every woman is a doctor? But the that phrase doctor, very much like scientist, right, brings with it a certain kind of clout, right, and gives you a certain kind of authority. And so you might think that certain kinds of fields lack that authority, right, and so they shouldn't be treated as having the power that a proper doctor or a proper scientist gets when it comes to knowledge claims. And I think that's part of the reason why there's such a gray area here and it's so messy, right? Is we tie science to prestige and authority in many fields. In some circles, you actually see science as kind of a degenerative thing, right? To call something scientific is to think of it as in some way dehumanizing it. You might ridicule something or dismiss it as being overly scientific, right? And there you're calling something science because you're saying it lacks depth or heart or emotion, or it doesn't really capture something true about humanity. And so there's this weird kind of social stuff when it comes to our science categorizations. Anyways, so what we're trying to do in a course like this, definitely for the first half, is we're trying to give an account of, well, what is science? How do we identify the things that are sciences? So we've said, look, there's a bunch of different ways people study the world. Physics seems like it's a science. Biology does, chemistry. Maybe there's some other fields. And when we look at these other things that we typically call not sciences, English, philosophy, some of the social sciences, things get muddy, but we can kind of make this distinction, right? You've got physics on one end, at least not theoretical physics, physics and chemistry. And then on the other end, you've got, English, right? And poetry, right? So what makes poetry different from chemistry, right? And so that's what we're trying to do, is give an account of that. And how we answer that question is going to change the types of things that you call sciences. Some people use the term science very broadly. It's just a methodology where you're attempting to assess ideas and solve problems using observation and experience. You get a theory out there, you come up with some sort of experiment or some sort of design that's going to test your theory because it's going to produce some data, and then you use that data to revise your theory, right? Now, if that's your view of what science is, well, it's going to be very, very broad. And it's going to perhaps be too inclusive. Other people have narrowly tied science to a very specific historical phenomenon, right? To a very specific kind of research that, well, not developing in ancient Greece, right? But has its roots in the ancient Mediterranean world. Gets spread through parts of the Middle East and sort of survives a little bit during the Middle Ages under this what we're going to call the scholastic tradition, and then really gets going during 16th and 17th century Europe. And so if you got a view like that, then you're tying science to a very specific time and place and a very specific way of thinking about reality that historically develops and sort of spreads and thrives post 17th century. Right now, that's going to give you a model of science that captures key European thinkers like Copernicus, Kepler, Galileo, Boyle, Newton, Descartes, and it'll really clearly distinguish science from other ways of investigating the world, such as farming, architecture, philosophy, pedagogy, and even math. But I mean, perhaps that's too exclusive, and maybe we should understand science more broadly than that. At a minimum, our theory of what science is should address the following. It should give us a general understanding of how humans gave knowledge about the world. What is the method by which humans can actually come to understand the real world as it is? What do scientists think they're doing? And then it should give us an understanding of what makes the work that descended from the scientific revolution different from other kinds of investigation of the world, right? Because it's true that science is in some ways historically tied, at least in the West, to very specific cultural phenomenon. What was that? What was the scientific revolution? What happened there? And what has carried forward from there that we're going to call science? We do want to include that, right? So you need an account of what was unique about this thing that developed, and then what's the method today that characterizes the sciences. So again, we can ask these questions. Again, what are we trying to give a theory of? Is it scientific thinking? Are we trying to give a theory that unifies all the sciences themselves? Many people thought that's what they were trying to do. How do all the sciences and how do all the scientific theories fit together? Are we trying to give a model of the methodology of the sciences? Are we trying to give a proper account of the scientific method? What we're going to see throughout the first half of this course is a bunch of philosophers trying to pick up these questions. They're going to give different theories. Here's what science is in the business of doing. This is what makes science unique from other ways of knowing. Right. So that's where we're going to start the course. A couple more things I want to talk about. When we're giving a theory of science, when we're giving a theory of anything, there's a distinction between what we call descriptive and normative theories. Descriptive theories, they tell us what happens. They describe the world. This is a distinction, I don't know why, but this is a distinction which people often have a very hard time making. So spend a bit of time on this. But if you're giving a descriptive account, what you're doing is you're describing what people do, and you're trying not to make any value judgments. So if you're giving a descriptive account of science, what you're doing is you're not saying this is how science should be done. You're just saying this is what scientists actually do. So you're identifying this thing called science, or these people called scientists, and then you're just trying to describe their behaviors, right? Without making any claims about what they ought to do or should do. By contrast, normative theories, they're not describing what people actually do. They're telling us what they should do. So like a descriptive theory of the sciences, right? What it would do is it would find anybody that's properly called a scientist, whoever that is, and it would just describe their behavior. So you'd go look at the physics department and the biology department and the chemistry department and any other group of people that are properly called scientists, and you would just look at what they do, and then you would give an account of that and go, that's science. The behaviors they're engaged in, that's science. A normative theory would say, I don't care what they're doing over in the biology department or the physics department. Here's what science is. If those are scientists over there, then this is what they're doing. And if they aren't doing this, then we might call them scientists, but they're not scientists, right? So very different. The philosophical project, especially for the first half of this course, was focused on this normative project. They really weren't interested in what real world scientists actually do or did. What they were interested in is when science is done properly, what is it? What do scientists actually do when they're being good scientists? So there's these value claims, good and bad, right and wrong, right? You could be a scientist with a PhD from, Oxford, and you could be a horrible scientist on a normative theory because you just do it wrong, right? And so normative theory, that's what it's trying to do, is give us an account of how we should do something. When you, maybe I'll say a bit more about normative versus descriptive claims. When you write college papers, or again, many of you are going to be teachers, you're going to assign papers to your students. Your professors use a rubric, right? This is a normative theory of what a paper should look like. And that you grade your students based upon how close their papers align to that rubric, right? When you're writing a paper. In some sense, if your goal is to get a good grade, right, you should be trying to figure out, well, what is the standard that this paper is being graded on? What does the A paper or the B paper or whatever grade I'm looking for, what does that look like? And then how do I write that, right? You shouldn't be aiming to do sort of whatever you want on a normative account, right? You should be trying to figure out what the standards are and then how to satisfy those. When we talk about science this way on a normative theory, right, we have a rubric. We have, this is the proper methodology of the sciences. And so well done science will live up to that, and poor science will fail to do that. When people talk about pseudoscience versus science, right, often this is the kind of rubric they use. This is the kind of distinction they use. They go, well, pseudoscience, looks a lot like science, but it fails on these normative grounds. It doesn't do the types of things that it has to do to be good science. Descriptive accounts, by contrast, they just focus on what actually happens, not how should we do it, but how have we actually done it? What are these groups of people actually doing? Many theories will throw these two things together, especially later theories. I think when you look at the early philosophy, so the next 4 weeks or so of this course, most people are in the business, everybody we're looking at is going to be in the business of giving normative accounts. But they're also going to be normative accounts that are going to try to capture what exemplar scientists are doing. So they're going to have this descriptive component in, this is what you ought to do, but it's also what scientists have actually done. And so, and that's always a problem with a normative theory of a real world phenomenon, right? If you're trying to say this is how people should behave, and then you think that there's some people that have actually behaved that way in the world, and it turns out that they haven't, well, that's a problem with your normative theory then, right? Because even though it's telling us this is how you ought to do something, it's telling you this is how you ought to do something that people actually do. And if they don't do that, problem with your normative theory. And we'll see that when we start looking at actual science, it very often fails to look anything like normative theories have claimed that it should look. So it seems like if some of these theories that we're going to call theories of science are correct, well, they're describing something that humans just don't do, or at least the people we call scientists don't do. Anyways, that is the first lecture. So again, if you want a little bit more on arguments, I've got a video that I'm going to post shortly on the difference between deductive and inductive arguments. Because that distinction plays such an important role in generating a lot of the questions people have about what science is, it's useful for you to sort of have that background. So I encourage you to watch that. But up next, so next week, we're going to talk about the history of science. We'll start with, at least in the West, we'll start with ancient Greece, and we'll work our way up to the scientific revolution and try to figure out, well, what exactly changed historically with the development of the sciences. Anyways, take care.